Welcome back. Yesterday we were starting to work on the voice interface so you can talk to MCPs, NCPs, sorry. And we did a lot of planning. And today we're going to do more planning because we're actually not done with all the planning, even though, if you recall, where we ended was around here. Right, so it starts to suggest now that we should do the implementation. But actually, if we look at the tasks it has done so far, there are a lot of the tasks that are not done, and all of these tasks are about planning. So we need to make sure that we're doing that first. Okay, so we go back to our terminal, and or rather, we're going back to OneUp code. We're just asking it here. Cool. So what we ask it to do here is to look at the tasks that we've already defined and then go through those tasks one by one. So a lot of these tasks is about planning. And so if we go back to our screen here where we had the actual planning, you'll see create designs, create requirements, and so on and so forth, and create test cases. We have 0 test cases in all of this. So we needed to actually plan these things and make sure that that's done correctly. And this is absolutely key because part of this whole idea that we're building up here is first, we generate a lot of context around each of the aspects. We make sure that these pieces of context are fitting well together. And then finally, we're going to test it. So we have this whole traditional workflow, but now built out for AI instead. And this is exactly what we want to get working here. So we want to get to a point where we don't need to do much. And instead, the AI is building out all of the tasks. And we see it has a bunch of problems here. It should be able to figure this out by itself. But actually, rather than using the framework, it now starts to read the files manually. And so let's have a look. Okay, it's not supposed to do that. It's supposed to use the MCP server. And it's just trying to validate all. Let's see. You'll complain about that. Okay. And now it's actually skipping the framework. So I still have some work to do on the MCP server here. It does manage to, let's allow that. It does manage to update some of the to-dos and promote some of them. So, and some of them are in progress. Some of them are in the backlog. Let's have a look here. See, we now have 18 that are done, which is a lot of the planning that we're doing. So when we look here at the tree, we can see all of these green little dots for the things that we have done. And now it also starts to create new tasks. So let's see, what is this task about? So this is implementing the audio manager component. So that's the specific task for that. And you'll see it comes nicely out with acceptance criteria, what steps we need to take, and so on and so forth. So I think this is all looking great. And if we go back to the feature here, we go to the to-do list, we can see what we are having of different to-dos here that it still needs to do. But as you can see, one of the things we're doing here is we're putting so much effort into the planning because the context is so crucial here. And so the hypothesis is very simple. 2026 is going to be about specs. It's going to be about how we are interacting with the AI. It's not going to be about code. So code is something that belongs to the past at this point, or at least that's what it would imply if we are even close to the singularity. And so what this means is we need to get to the point where the instructions we're giving are so well organized that the AI can navigate it, can figure out what it needs to do for the next thing, and automatically create this context. And this is what all the big companies are about to do. And this is also the principles that I'm teaching at Compound Coders. So what you'll see there is that the first thing we go through is how do we do accurate prompting? What are the pitfalls? And then the second thing is how do we do chaining? And the third thing is how do we do evaluation? And the nice thing about these principles is that they apply whether you're using LLM manually, whether it's semi-automatic or whether it's fully automatic. And so what we're trying to do here with the MCP server is actually make this whole framework completely automatic so you don't have to do a thing. Now, whether or not we will succeed at this is a completely different question. So I still have a lot of skepticism around whether the singularity is actually here. I think a lot of it is just hype. But what is true for sure is that LLMs are better than they ever were at doing these tasks. And so our job is to make sure that it has all of the context it needs and is positioned to do the best work it can do. Okay, so now we see that it's actually come up with a plan for what we should do and which order we should do it in. And I wonder if it has defined the tests, because it should have done that, but I am not entirely sure that it did do that. See if we can find one of the ones where it says it has to design tests. Okay, so it claims that this one is done. I don't see any tests anywhere. So this is another small issue with the MCP server. So normally this should make that the tests appear as a separate entity in here, just like we have requirements and we have the designs. We should also have tests in here. And so this is something that I need to put on my to-do list to actually get to work better. Anyway, let's just see if we go back to this one here and we then have a look. We have two features. So it claims to have done all of the test stuff. Feel inclined to just check this manually to see if it actually has done the documents and this is a UI problem or it is a protocol problem. I guess I'll do that after this live stream. Let's get on with it, right? So we want to build out the tests now, or build out the implementation. Yes, please proceed. The implementation in the order you have described. Okay. So one thing you will notice here is it's actually a relatively detailed plan is coming up with, right? So it starts by setting up the project. It has a description for that. It's then creating the storage manager, which it also has a description on. Then it creates a core audio manager. It creates a OpenAI real-time client, an interview controller, the Tari commands, set up the view, set up the interview, and all of that. So it has a lot of stuff, and all of and while it's going through each of these tasks, it'll be updating the to-dos in the ACE framework and using this to make sure that we have a very, very tight grip on what we're doing and when we're doing it, and making sure that the right description is at the right place when we need it. And if we refresh this one again here, we can see the backlog is counting 36 items. That still needs to be done. And I think the designs, these ones could actually be considered done. All they need to be is be approved. Let's see what are the children actually of these ones. Okay, so with the design, we have to, this enables, okay, so the reason why this is not done is we have a task here, and that task is how we implement the design of the audio manager. So if we look here, it has the steps we need to implement, and we should be able to go back to the design and then have a look at, yes, so you see the design is related to the audio manager, and now it has made some information here that's quite crucial, and then it's made a specific task. It has a very comprehensive diagram here. Arguably, this task it's come up with is a bit too simple for the actual details that are here, because these are way more complex. Let's see how it gets on. Just going to take a small break from while we're doing all of this. Okay, so we have 27 done, still 36 in the backlog. The other thing you will notice here is that the way everything is arranged, we can take a much more high-level overview of how we're going about our development. Right? It becomes more about making it user-centric in what are the use cases of what we're doing here, how do I get the specific user flow I want, and then first when we have that user flow, you start defining all of the other components around it. And so in many ways, this way of setting things up is very close to how you would do regular software development, right? So normally you have a project manager that defines some use case, or maybe that even comes more from the product side, and then that's given to the project manager. This is broken down into smaller requirements, and then these are passed on to the developers. Developers implement each of the smaller things. It's then going through a QA process, and this is exactly what we are trying to replicate here. So the key idea here is that we want this to be you could say a memory of the LLM of all of the stuff it's done, but basically a track record of every single decision that was ever made for the project, with clear receipt of doing for everything that was done. Now the receipts are not there yet. This is still one of the things I need to get implemented in the ACE framework's actual implementation, or in the MPC version of it. Obviously, you can do all of this when you're doing it manually, but by doing this automatically, we can get to a point where we get this whole DAG of things that are happening, and then having individual receipts. So when we're looking at how was a specific requirement implemented, we can see, okay, this was the steps that was taken, this was what was done. And this is super useful because it means that these commands that you see here and what was written to specific files can be recorded right into the DAG that we're building up. And so later on, when the LLM needs to go and work on a different task, it'll be able to search for the components we have previously built, find small pieces of context that actually describes how that component works, and for instance, find a design document that drove that implementation, use that to make sure that it actually does its best work. And at the same time, we hopefully will have the interfaces generated, we'll have what was implemented when, so when we are reviewing these things, we can go and look at this on a requirement to requirement basis, which will help us a lot in understanding that how different parts of the system is working. The other thing that I think is really interesting is the idea of being able to talk to this collective DAG memory that we're having, right? So you can imagine building up a LLM that has the possibility of searching this, and we can now ask it questions about the architecture, about the decision that was made. And because we can follow decisions and requirements and use cases and all this through the DAG, it should be relatively easy to start from one point and then follow it back to the feature and say, okay, well, this is actually where it all collides. So one of the things I want to extend this with is a more. So one of the things I actually want to extend this with is a provenance system where you cannot do anything without relating it to a specific part of the DAG. This will help keep the LLM honest about what it's doing right now, and also make sure that its attention is always directed back into what it should be doing. Now, I can't do this easily with Claude Code or with any of the other tools out there. And so the reason for this is that they will always be putting in their own tools, but I can do this with OneUp Code. And this is exactly what's going to happen with the Pro version, that we'll have a set of tools that can do the same things as Claude Code can do. But what they will do differently is they will make sure that you have this provenance tracking throughout the system. And that's going to be super cool because it will, in that way, you're always directing the LLM's attention back into the DAG. And I think this is probably one of the most powerful ideas, because it makes that whenever the LLM is doing a command, it has to constantly think about what is it doing, what is the context, and the context is always coming back to it for that specific part. Whether this will be token efficient is another question, but I have ideas on how we were going to solve this. But first, we need to get the space system working. And I think this is going to be absolutely crucial if we are to hope for that software just develops itself with us just telling it what it should look like. Okay, so I think this is going to take quite a bit of time. We have started the process now of implementing it. I suggest we just leave it here and let it run overnight, and then we can see tomorrow, how did this go? Did we manage to get a voice app that's actually working? And what can we learn from that? I hope you have enjoyed this live stream, and if you did, remember to subscribe, and see you tomorrow.